What's up, math scholars? Hopefully you're excited to join me for a video lesson on radicals, day 4. We are going to learn how to rationalize some denominators. So everything we'll be working with today will be fractions. Make sure you're listening for the keywords and make sure you do the little mini quiz after you finish the video, okay? And the homework tonight will be the radicals worksheet day 4, which I believe is just a front side only paper, if I'm remembering right, okay? All right, let's start by talking about what rationalize means. You are never allowed to have a radical in your denominator in a final solution. So what they want you to do is something called rationalize. It's up to you if you write this definition down. But rationalize means remove the radical from the denominator by multiplying by the same radical on the top and the bottom. Go ahead and maybe jot that down, and I'll explain why you have to multiply the same thing on the top as you do on the bottom. Again, if I ever get going too fast, just hit pause or rewind the video to catch yourself up. You should be taking notes and doing these problems along with me on paper. All right, so in this problem, my original problem is 7 over radical 2. I'm going to be multiplying the top and bottom by radical 2. And the reason I have to have the same thing on the top and bottom is that has the overall value of 1. So it's not going to change the overall value of the original math problem. Okay. So multiplying straight across the top, 7 times radical 2 would be written 7 radical 2. 7 is not in jail and 2 is. That's why they have to remain separate. Radical 2 times radical 2, they're both in jail, so you can make that a radical 4. And what you've basically done here is you created a perfect square for yourself in that denominator. And the square root of 4 just equals 2, and voila, we don't have a radical in our denominator anymore. So we just did what was called rationalize. Okay, so that's your final answer. Easy enough? All right, let's go ahead and try our second one. Jot it down. All right, our goal is to get all those square roots out of the bottom. So we're going to multiply by the square root of 3 over the square root of 3. Again, you might be tempted to put a square root of 5 up there, but you have to have the same number on the top and bottom. So we're multiplying by the equivalent of 1. On the top, then, I would have the square root of 15. That would not simplify at all. You wouldn't have any factors that could break out of jail. On the bottom, you end up with square root of 9. And the square root of 9, that's a perfect square. It equals 3. So you're done. You are all rationalized. Thought this would be a good time to tell you my first key word of the lesson. The first key word of the lesson is summer. Because let's face it, who's not excited that summer is coming? Woo! Makes me happy. All right, we got square root of 10 over square root 2. Go ahead and jot that down. We're going to multiply by the square root of 2 on top and bottom, giving us radical 20 and radical 4. Now let's talk a little bit more about this one. This is the first one we've seen where we can do a little simplifying. The square root of 4 equals 2. That was easy. It's a perfect square. But radical 20, you're going to want to either use your perfect square method or your jailbreak method to break this guy's out of jail a little bit. It looks like the square root of 20, a 2 can break out of jail. So this group of 2, the group leader gets out of jail. The other one falls in the hole. So the 2's out of jail. But the 5 has to stay in because he didn't have anybody to join his group. Oh my gosh, would you look at that? This one's cool. Now that we have a 2 on the top and a 2 on the bottom, those 2's actually can cancel. This bundle's answer is radical 5. Which you might have been able to predict originally from the original problem. 10 divided by 2 is 5. So it's kind of cool to discover that, though. All right, so since on the last one we kind of discovered that 10 divided by 2 is 5, I'll kind of talk you through this one. You are allowed to put that 8 and 2 in one huge radical, and 8 divided by 2 is 4, and then the square root of 4 is 2. Now that we've discovered that quotient trick, we can do problems like that. All right, let's try this one. Square root 2 over square root 5. I don't think those are perfect squares or anything, so I'm actually going to do it in reverse and make the radical 2 his own radical, make the radical 5 his own radical, and now we'll work on rationalizing. Why don't you pause the video and try this one all by yourself and hit play when you're ready to check. All right, you're back and ready to check. We're going to do a radical 5 on top and bottom, making it a radical 10 on the top and a radical 25 on bottom. Our final answer is radical 10 over 5. Now, if you can skip that step and you realize the answer is just going to be a 5, you don't have to actually write that radical 25 step. That would be fine with me. Ooh, this one's getting a little bit bigger. We've got 10 over 2 radical 2. Go ahead and jot it down. Alright, so since the only thing we're truly trying to rationalize here is that square root 2, you're only going to need a square root 2 and a square root 2 like so. Now on the top it'll be 10 radical 2. On the bottom it'll be 2 times radical of 4. The square root of 4 equals 2, and 2 times 2 is 4. So this is what I'm looking at about now. Now you would want to simplify the top and bottom by factoring out any common factor that the 10 and 4 have in common. The 10 and 4 definitely could both divide by 2. So 10 divided by 2 is 5. 4 divided by 2 is 2. And then the radical 2 can just stay down. So our final answer, 5 radical 2 over 2. Sounds like a good time to give you our second key word of the lesson. Our second key word of the lesson is birthday. Because I have a birthday coming up on June 9th, so I'll be at home celebrating my birthday, because there's never any school on June 9th. So shout out to all you summer birthdays who can celebrate in the summertime with no school. So keyword number 2, birthday. Ooh, man, this one's getting big. Let's go ahead and try it. Write it down. It's the denominator we're trying to rationalize. So what we're going to multiply by is a square root of 3 on top and bottom. Now the 5 just kind of stays put. He's his normal integer, but the radical 6 and radical 3 can become radical 18. I think that's probably going to reduce, so keep that in mind. On the bottom, 2, and then both radical 3's would make a radical 9. So radical 9 equals 3, of course, and 2 times 3 is 6. I think our bottom number is going to be a 6. Let's work on the top of it. Down here where I have some space, I'm going to work on breaking this 18 down and seeing if I can get anybody out of jail. It does look like we're going to get these 3's out of jail. So as they run out of jail, one guy falls in a hole. So radical 18 can be written as 3 radical 2. Now keep in mind, we had that 5 up there, and that 5 is going to be out front with the 3. So I believe that would look like this. 15 radical 2. So just think to yourself, yes or no, do you think we're done, or do you think we can simplify the fraction we've got a little further? We actually can simplify the fraction down a little further. 15 and 6 are both divisible by 3. So 15 divided by 3 is 5. 6 divided by 3 is 2, and that is what your final, most simplified answer would be. And the denominator has been rationalized because there's no radicals in the bottom. All right, I think we are about 9 minutes, 30 seconds in. That's long enough of a video. So you have the rest of the time to work on the did you hear about side of the worksheet. So it is only the front side. I would definitely do your work on a separate sheet of paper. And then don't forget to complete the mini quiz before you leave today in Polaris. Thanks for watching. Hopefully you're having a happy Tuesday.